In this video, we're going to look at another type of transformation called a reflection. Now recall that in a translation, we had to specify which translation it was by giving a vector, and then each point moved along that vector. In a reflection, we similarly have to have some object to define which reflection it is, and this time the object is a line. So this line here, let's make it purple. That is our line of reflection, our axis of reflection, or our mirror line. It might be called any of those things. So we have our mirror line. Okay? And we want to reflect. Well, it's pretty easy to do this in Sketchpad. What you do is you just click on the mirror line, go to Transform, and mark it as the mirror. There we go. Then select your pre-image points here and say Transform, Reflect. And I'll make the image points red, pre-image is in blue, and we'll label those. So that is the image A prime, the image of A. B is the pre-image, the B prime over here is its image, and there's C prime. And so we can see, regardless of what this looks like, we see a reflection over the line. So notice points on the one side of the line get moved to their images on the other side of the line, but points that are on the line itself are actually fixed. So here's a point right there on the line, which is its own pre-image equals its own image. Same point is equals pre-image and image, or equal. Same way for this point here. In fact, if we think of transforming not just this triangle, but the entire plane, then in fact, the entire set of fixed points is the line itself, the mirror line. Now, how can we see geometrically what's happening here? Well, let's take a look here. One thing we might want to do is connect up pre-image to image and construct a line segment. Let's just make this a little black line. Okay, and then similarly, maybe we could do the same thing for B and B prime, connect those up, and C prime. What do we notice about all of these line segments? Well, you may notice that they're all parallel to each other, and that they're all actually, if you look at this point of intersection here, it is actually the midpoint of that line. Midpoint of these lines here, connecting image and pre-image. And not only that, look at this angle here. What does it look like? Well, see, when it does this in Sketchpad, you know that's actually a right angle. So in fact, we see that the mirror line is a perpendicular bisector of the line connecting up pre-image to image. And so that will define what we mean by a reflection. Intuitively, we think of just flipping it over here. Notice if we were actually physically cut this out, we could place it on top of this, but to do it we have to remove it from the plane. We have to move it into the third dimension to flip it over and place it back on top of this. So in that sense, maybe a left shoe and a right shoe are three-dimensional reflections of each other, but you could only turn a left shoe into a right shoe if you could somehow go into the fourth dimension to do a flip or reflection. Just like here, to take the triangle, we have to take it into the third dimension to flip it over to put the blue triangle on top of the red one if we were to say cut it out. But of course we could actually do that. If you want to do this with tracing paper, what you would do is you would put your tracing paper down, you would trace this mirror line, and we would mark a couple of points on the mirror line, say here and here. Let me mark those. Those were actually the control points. So maybe we'll make those yellow. So you'll take those two. I didn't mean to make them that small. Let's see. To make them large. Okay, so take those 2 points, put a dot on those points where you can see it, and actually copy this line. Then trace this figure here. Then actually physically pick your paper up, flip it over to the other side, and put it back down so if this line stays on there and these 2 points stay fixed. then what you're going to see is it's going to be above the red points there. And so that'll give you a nice way to check this if you have tracing paper. So how are we going to construct this I showed you how to construct it in Sketchpad, but how do we see it here? So again, here's another example. Depending on where we put that mirror line, we get different images. But the mirror line is always a perpendicular bisector of each of these lines connecting up pre-image to image. Now let's do this as a construction with Geometer Sketch. Well, let's do it with the compass and straight edge. I'll use Geometer Sketchpad here, but I'll be using equivalents that are only compass and straight edge equivalents. Okay. So let's pick a point here. We want to find its mirror. Okay. So let's remember what we need to do. We need to be able to construct these line segments so that this mirror line, which we already have the pre-image, say C here, we need to construct this line segment, and then we'll have C prime over here if what? Or if C here, I'm sorry, C, the pre-image is here and the image is over here. So we have C and we want to find C prime over here. Well, we need to make this so that this is a perpendicular bisector of this. So remember, what shape has a perpendicular bisectors in it? Well, the diagonals of a rhombus have that. So we're just going to make a rhombus here in our construction. So here's the first step. Take your point A. We want to find its image. We find the mirror line and we make a circle. It can't be too short. It needs to be where it touches the line twice. So just as long as it touches twice, I've got those points H and I here. So anywhere you want where it touches twice. Now once you set that, we're not going to change it again until we find A prime. So in other words, we're going to set our compass one length. We don't have to make the full circle. We just have to make the part of it where it touches the line twice. And I would go ahead and make this arc here, at least make it around like, quit moving it, around here like this, so that we can see those 2 points and see that they are connected by that circle. Now without changing the compass, move to H and make an arc. It should go through A prime, A, and it's also going to go over here through A prime. So make the mark maybe starting over here and go over into here somewhere. You don't have to make, you could make the full circle, but you don't have to. I, similarly, you don't have to make the full circle. Just start over here at A and follow it till it hits in here. Go a little bit past, right in here. And then where that crosses, that's going to be A prime. Okay, so just to see that, notice we've made these two radii the same, all three radii the same. So that those two distances that you see there are the same. And let's see, I'm not showing the end of it, but this point right here is the end. So this line here and this one here are the same length, and so that makes a rhombus right there. And so no matter how big or how small we make this, as long as it touches that line twice, and we make all three of these marks the same radius, we've got us a rhombus. What do we know about a rhombus? Well, we know that its diagonals, when we draw this in, is a perpendicular bisector of the other diagonal from I to H, and more importantly, the one from I to H is a perpendicular bisector of this one. And so, in fact, this is going to be your A prime, is going to be this point right up there where they meet. Now, you don't have to actually draw the rhombus in, or you don't even have to draw in the line connecting the pre-image to image. So we could hide those if we want. We don't have to have these sides of the rhombus drawn in. It's important that you see them, I think, because of understanding what they represent. That we have a rhombus going from A to I to A prime, back to H, back to A prime, and that the diagonals are perpendicular bisectors, which makes A prime over here the image of A under this reflection. Now what do? We do the same setup for, say, B here. We take a circle centered at B. Here's a control point for that. I can use the same setting I used for A if I want. In fact, if I'll take the furthest point away, which looks like it's either probably C in this case, and make sure I get a circle big enough to touch the line twice, I can make all of my circles. You're going to have 3 for each image point that you want to make. So in this case I need 9 circles, or parts of 9 circles. I could make them all the same size, but what is important, we don't have to do that, but what is important is all of these circles that we use for B to find B prime are the same. So I can make that smaller or larger if I want. So I can, when I go from A to B, switch the size if I need to, but once I'm doing B, I need to make all 3 circles, this one, and this one have the same radius. So now again we get our rhombus there, and there's our line connecting pre-image to image. And so these 2 circles, again, let's go over what it is. Take a center, put your pointy end at B. The drawing end is going to touch the circle at 2 points, right here and right there. Move the pointy end to this one, draw part of a circle here. You don't have to draw this part over here, but at least draw the part going from B up into here somewhere, so make sure it's going to touch where B prime needs to be. Similarly, put the pointing end here, draw this circle here, draw the part that goes through B and across here, and you should be able to start here at B and follow these 2 parts together where the ones that meet at B, follow them, and where they meet at B prime is going to be that. Okay? And similarly, we can do the same thing for C. And now we're starting to get messy if you draw all of this in. But again, you don't have to draw in this part about the rhombus, which we have. You don't have to draw in the diagonal. So we can make it a little cleaner if we don't draw all that in. But it is important that you see that so you understand what's going on. But anyway, you want to draw, and again, you don't have to draw these full circles. You just got to make sure I would draw this one at least enough, maybe start over in here, go around here till it meets here twice. So draw it. You don't have to draw all this part down here. It's not important. Now, the important thing is to identify these 2 points. Then, again, I want to draw those, and notice they should go back through the original point C and through C prime. And again, the only part we really need is this part of the arc here and this part here. And then you should be able to follow those which start at C. You can take both fingers here and follow one this way and one this way, and they should come back and touch here at C prime. Now once you have A prime, B prime, and C prime, then you just connect them up to with the straight edge to find the ends. Okay? Now, in general, a reflection using a grid is a little bit harder to do, but certain ones are easy. If your grid line is vertical, it's real easy to use that. If your mirror line is vertical or horizontal, it's really easy to use that to make your perpendicular lines to it are going to be the other way. So if this one's vertical, the perpendiculars will be horizontal. So we're wanting these segments going out like this. And then we just count. So A, we go in, we have a vertical mirror line, the green line there. So we're going to the right horizontal to get to A prime. Notice it's going 2 in, so it goes to the other side. So A prime is going to be right here. At this point, I guess right now it's -1, 4. Okay? Similarly, B down here, we're going to the right 3, so you go 3 more, and it's going to get B primes right there. Do the same thing for C. Okay, C we're going 1, 2, 3, 4 in. We go 4 on the other side. Okay, and then D is even further. 1, 2, 3, 4, 5, 6, 7, 8, and then you go 8 the other side. So, but anyway, we can do that and then connect up those points there, and we find the image over there. Okay, in a similar way, if this is horizontal, let's put one that kind of goes through the middle of the figure here, then our grid lines our grid can help us. So we want our little segments here connecting pre-image and image are vertical. So this one going straight down 1 to get to the line, go down 1 more to get A prime down here. B is below, so we go up 2 to get to the line. We go up 2 more to get to its image, B prime. C's 1 below the mirror line. C prime will be 1 above. D's one below, so D prime would be one above, and then connect those, draw those, well, in this case 4 vertices, and connect them up, and we have that. Another one that's pretty easy to do is if this is at a slope 1 or -1, where it's right along, going corner to corner along our grid, either that way or where's my control point? There it is. Or this way. There we go. Then it's pretty easy to use that to help us. Now here's a point here that's actually on the line, so it's not going to move. So notice this point here, let's put it over here. So I can change this around. Okay, so say that's the one we want to reflect. Okay, actually let's put this one where it's, how about there? Okay, so if this line has slope 1, the one that's perpendicular will have slope -1. So it's just going to go in, and we just count the number of diagonal segments. So here we're going in one diagonal, that'd be a length of square root of 2, and here we go square root of 2, or one diagonal going the other way. So A prime is going to end up right there. B prime, you go in 1/2 of a diagonal, so you go half a diagonal here. C goes in 1.5 diagonals, it's going to be 1.5 more on the other side for C prime right there. D goes in 1, 2, 3 diagonals, so 3 diagonals on this side is going to give me my image down there, D prime, and then connect up the dots, and now you have that. So that's a particular one where the grid is a little bit helpful. Now, you can also use a grid for other directions, and it can still be done, but it's a little bit more complicated. So here, for example, this line has slope, let's see, we go to the right 1, 2, 3, and up 1. So the line should go the right 1 and down 3. Right 1, down 3. And so that we can put a dot there, and that's going to give us our line that we need to go on. So we could draw that line in, maybe a ray going out this way, and then we have to count. We're going the right 1 and down. So it's a little harder to tell exactly how far we went to get to this point here. So in this case, it's a little harder to see our image. And in fact, our image wasn't even a lattice polygon in this case. So it's a little harder to do in that case. Not impossible to use the grid to do it. You can. But it's not as helpful as it is when that's at a 45-degree angle that way, or -45-degree direction angle here, or even easier if it's vertical or horizontal. Okay, so in our next video we'll look about how does this relate to at least a couple of specific examples of how this ties into equations.